Now let's find out where the function is concave up or concave down. First, we have to start with the domain again of the original function, which is a number line with two blank circles, one at -1 and one at +1, which gives 3 columns to our table. Now we have to find the second derivative of the function. Since this is the first derivative, our second derivative is nothing else but 2 times 1 minus x squared minus 2x times 1 minus x squared times minus 2x over 1 minus x squared to the power of 4. Now let's simplify with this factor. It leaves us 2 minus 2x squared plus 8x squared over 1 minus x squared cubed, which is nothing else but 2 plus 6x squared over 1 minus x squared cubed. Now we have to find the zeros of this function. For that we have to solve this equation, and we can clearly see that this is not possible. Which means there are no critical points, so our table stay like this and gives us intervals like x is smaller than -1, x is between -1 and 1, and x is greater than 1. Now we have to find the signs of the second derivative function on these intervals. This is the second derivative function. We can clearly see that the top is always positive, which means we only have to consider the bottom. At the bottom we have a composite function, and the outside function is a cubic function which doesn't change the signs of the values. Therefore, we only have to consider the inside function, which is 1 minus x squared. Because of the negative x squared, this is a depressed parabola, and we know that the zeros are -1 and 1. So we can see that here is negative, here is positive, here is negative again. Therefore, we have negative here, positive here, and negative here. According to these rules, the original function is concave down here, concave up here, concave down here. Now, it wasn't a question, but since -1 and 1 are not in our domain, there cannot be inflection points there. So let's see what we know about the graph now, the graph of the original function. Now, according to our table, we can see that on these intervals is concave down, here is concave up, here is concave down again.